Hello everyone. Am I audible, guys? A quick yes or no through the chat box. Okay. So welcome everyone in the second session of our course. So yesterday, as we discussed what is data science, machine learning, and artificial intelligence, and then we also discussed about the different types of data and different data types based on their organization. Then we understood relationship between data science, machine learning, and AI. Okay. So today what we are going to do is, at a very high level, we will try to understand what are the different stages through which any AI project will go through. Okay, so that's the core agenda of today's session. And so before I start, once again, I'll request all of you that kindly turn off your video feed, because we don't need video is not something which we require for this particular session. Okay, so let's get started with the different stages through which any AI project will go through. Okay. Now there are multiple frameworks which talks about, say, the different stages. Okay. But then here in this class, we are going to discuss about two frameworks. One is Osman framework. Urmila and Akhil, kindly turn off your video. Yeah. So we are going to discuss this Osman framework, where we have 5 different stages through which any AI project will go through. Okay. So in this Osman framework, O stands for obtain, S for scrub, E for explore, M for model, and I for interpret. Okay. Now let's try to understand what exactly these 5 different stages are. So yesterday, as we discussed, when it comes to AI, data is what is at the core. Okay. So the first stage of obtain is where we need to understand the business problem. Okay, when it comes to any AI project, it's very important that you understand your business problem, or say the business objective. Once we are clear about the business problem or the business objective, then in obtain stage, you try to collect the relevant data. Okay, and that's the reason this stage is also known as data generation. So what do we do in obtain? In obtain, you first understand the business problem. Am I audible, guys? Sampath, kindly check your audio connection, because I'm audible to other participants. Okay. So yeah, business problem or objective. Then once you are clear about business problem or say objective, then the next task is to collect the relevant data. Now, once we have the relevant data, next step is Scrum. Okay. I hope you all remember that yesterday we discussed about structured and unstructured data. Okay. So can you guys quickly tell me what's the definition of structured data and what's the definition of unstructured data? You can ping me your answer through the chat box. Formatted data schema is fixed. Unformatted data schema is not fixed. Yeah. So yesterday, as we discussed, structured data is where schema is predefined. Unstructured data where schema is not defined. Right. Yeah. So, and I also said that when it comes to AI, mostly we are going to be dealing with unstructured data. Okay. And the moment we talk about unstructured data, these data sets are going to be full of noises. So, in the scrub phase, which is also known as pre-processing. Okay. So, in the second stage, what we do is we try to clean the data. Okay. Clean data, or in simple terms, let's call it remove noise. Okay. Now, the first two stages are understand the business problem, collect the relevant data, and remove the noise or pre-process your data. Once you are done with pre-processing, the next step in any AI project is explore. So what do we need to do in exploration? It's all about you explore your data through multiple different techniques to understand what are the patterns. Why? Because those patterns is what is going to be important when you start your training of model. Okay. So the third step is explore, where mining. What do we mean by mining? Try to understand the pattern that is available in your data, because that is what is going to be helpful while training the model. Okay. So say pattern identification. Okay. And again, data mining can be done through multiple different techniques, right? There are certain statistical technique, then you have visual techniques, then you also, what we sometimes do is we use our domain knowledge to understand the pattern which is available in the data set. Okay. So before I go ahead and talk about the modeling phase, let's try to understand, obtain, scrub, and explore using an example. See, the business problem in obtain is sentiment classification, or objective is sentiment classification. Means given any review, we need to classify that review into positive, negative, or neutral. Okay. Now, the moment we are clear about the business problem, we'll have to understand about, or we'll have to collect the data, the relevant data. Now, when it comes to say solving a problem statement for this particular objective, what we need lot of reviews. And how can we get these reviews? You have platforms like Amazon, Flipkart, okay, then IMDb. Then sometimes there are comments which are also available on YouTube. So it depends basically which domain you are working in. Based on your domain, you can pick multiple resources or platforms which are available online, where they simply gather the review. Okay. So now once you extract the reviews, but then can we use this as it is for classification? No. Okay. So what we need is, you will have to have a manual team which will tag that data. Say for example, I hope you all remember that housing example, the property price prediction. So what happens is, if we want to train a machine learning model to predict the property price, what kind of data we need? We need a data set where you have all the features which are important for property price prediction. And at the same time, we need property price for all those reviews. Similarly, when it comes to say sentiment classification in this case, we will, when it comes to extracting the reviews, we can get that from all the sources which I have mentioned here. Okay. But then a manual team will do tagging, like say if we have a review, product is good, so manual team will tag this as, okay, this is positive sentiment. Say delivery is good, so the sentiment here is also positive. Now say product is not good, so sentiment of this is going to be negative, right? So what do we need? We need to generate tagged data points like this. Okay. Now say once we are done with collection of data, and you also have say the tagged data, then in pre-processing step, what we need to do, we need to think about, say, different types of noise which we might have in this. Now what happens is, the moment you are, say, crawling from, if you are gathering your data sets from the online platforms like Amazon, Flipkart, IMDb, or YouTube, many a time what happens is you will end up extracting the HTML tags like, say, body. Okay. Similarly, so your review in this case will look like product is good. And this is what a tag, which is actually used for web portals. Okay. This has nothing to do with the review, but then because of some automated crawls, say if this is part of your data. So are we supposed to train our model with this information? Not at all. Okay. Similarly, what can happen is, sometime, say, because of some machine failure or system extraction issues, your review is not complete. Say, for example, product is, that's it. Okay. Now, can we assign any sentiment to this? No. Then imagine a situation where multiple reviews got crawled, or say dumped in your database. Sorry, same reviews got dumped in your database multiple times. Say product is good, product is good. Okay. And say if this got dumped 100 times, so are we gonna keep all these records, or are we gonna keep these duplicate records? No. Okay. So this is what we mean by noise. So whatever example I have listed here, this is what noise which we can encounter in order to say, train a model for sentiment classification, right? So as we go and say discuss more in this course, we are going to be discussing multiple other noises. Okay, in audio you can have a totally different noise, then say in image we can have a totally different noise, in text also we are going to discuss multiple other noises. But then the key takeaway here is that noise is what? Unwanted information. Okay, which ideally should not be part of the modeling process. So what we are going to do in pre-processing part, we are going to remove such noises. Okay. And there are techniques which we will discuss. Many of these techniques are, say, completely manual. There are techniques which are semi-automated, and there are also techniques which are completely automated. Okay. But then the key takeaway in pre-processing, what do? We try to simply clean our data, or say remove the noise. Now let's talk about mining. What did I say about mining? In mining, using exploration or visualization, what we try to do is we try to understand the patterns, okay? Because that can be very helpful, say, in the modeling process. Now, what kind of pattern we can identify in this case? Say, what we can do is maybe we can identify that when it comes to positive reviews, what are the most dominating words in the entire data set? Okay. Similarly, when it comes to negative, what are the most dominating word? Okay. Is, say, sentiment of a review is also prone to case. Say, for example, if I tell you that we have a review, product is good, and say someone gave 2 star, but then we have a review, product is awesome, and someone gave 4 star. Okay. Now, what can we infer from this? That when it comes to sentiment, or say reviews, people use capital letters to highlight something. Okay. So while training the model, we can somehow pass this information that, say, case of words is also important. So this is what we mean by pattern identification. So in mining, what we do is, or say in explore phase, we try to understand the patterns which are going to be helpful for the modeling phase. Okay. Am I clear till this point, guys? A quick yes or no through the chat box. Okay. Next, one of the most important stages, say when we talk about modeling. Okay. So underneath modeling, there are 3 different tasks which we perform. One is partition, then modeling, and then evaluation. Okay, so let's try to understand what these three different stages are. See, say if I tell you that for the same sentiment classification, if we have 10,000 reviews, or let's call it 10,000 tagged reviews, and these reviews are tagged, means for all these reviews, say we have the sentiment information or sentiment class information like positive or negative. Now, say if we have a machine learning model M1 trained on this data set. So let's assume that this model is what? Where given any review, okay, given any review text, it will predict whether the review is positive or negative. What exactly is happening inside M1 is something which we will discuss later. Actually, this course is all about the algorithms which can be used, right? But then as of now, let's assume that this machine learning model M1 here is a black box which receives review text as input and predicts sentiment, which is positive or negative, right? Now, say if we have trained this data set on the 10,000 reviews that we have, okay? The question is, before we put a say or before we deploy this model in production, say for real life use, what we'll have to do? We'll have to evaluate this model, right? Without evaluation, without properly evaluating a model, we cannot simply deploy that model in production, right? So what we need? We need a way by which we can evaluate this model. Okay. Now, say if we need to evaluate this model, and if I tell you that, okay, I have a data set where you have multiple, um, say, multiple records, okay, let's call it ds underscore 2. Okay. R3, and then means we have multiple records. In each record, we have the bedroom information, then the balcony information, then area of the property, and so on. And then I'm also given the property price, say something like 2000 INR. Now, say, can we use this data set for evaluating M1? Guys, my question is simple. Here we have a DS2, okay, data set 2. In data set 2, we have multiple records, and all these records are about property features, and then we have a property price. So my question is, if we have trained a model M1 for predicting sentiment of a review, can we use this second data set for evaluating this model M1? Yes or no? No, of course not, because there is no relation, right? So basically what happens is, when it comes to evaluating a model, what do we need? We need a similar data set as training data set. Means whatever data, say, we would have used while training. So while evaluation also, what we need? We need a similar data set. But then at the same time, we will have to make sure that while evaluating, we use a data set which is completely unseen to the model. Okay. Now, if that's not completely clear, bear with me. I'll explain that using an example. Say if we have uh, okay, let's say this M1 is nothing but student, okay, and we are trying to teach a concept of addition and subtraction to a student. So say S1, and addition and subtraction. So say while training or while teaching concept of addition, if say a tutor used these examples, okay, and say 4 minus 2 equal to 2 and 5 minus 3 equal to 2. Okay, so say tutor used these many examples to teach the student one, what is addition and what is subtraction. Now say when it comes to evaluating whether S1 understood the concept or not, what can we do? Tutor in test phase can give few examples like, say, he or she can ask the student, hey, tell me what's 2 plus 2. Now, do you think this is the right way of evaluating? No, again, this is not the right way of evaluating. Why? Because if you ask the same example, say here in the training, you have also, we have used 2 plus 2, right? So what happens is, you might have a student who will focus only on memorizing the stuff rather than understanding the concept, right? So in order to properly evaluate whether a student understood the concept of addition or not, ideally what we should do is we should use or we should ask questions which are similar but then at the same time unseen to the student, right? So maybe what we can do is we can ask, say something like, hey, can you tell me what is 3 plus 5? And say if student replies 8, means you have strong reasons to believe that, okay, student understood the concept of addition. Similarly, to check subtraction, what you can do is maybe you can ask what is 6 minus 3, and if you get 3 as answer, now as a tutor you have strong reasons to believe that a student understood the concept of subtraction, right? So what we are doing here is, let's assume this S1 is our model, and here we are trying to evaluate that model before we say that, okay, now you know the understand concept of addition or subtraction. How have we evaluated here? So we have here evaluated using, say, these two examples. Now these two examples, if you try to compare, let's call this test data set, and let's call these examples as train data set, right? So if we try to compare these, this test data set is what? If S1 is model, it's unseen to S1, and as well as it's a similar to the data which we have used while training, or call it tutoring. Okay, so this is what we always need to keep in our mind whenever we need to evaluate a model. The best way of doing that is we should partition our data set into two splits: train data set and test data set. Now maximum data set we should keep in train data set, because we should use maximum data set for training the model, and we should keep sufficient data set in test data set for evaluating the model. So what happens is, if we partition the same data set into two part, train and test, you know that test data set is going to be unseen to the model, but then at the same time similar to the training data set. And that is the whole purpose behind partitioning your data set. Okay, so say if you have 100 records in your data set, 1 2 3 till 100, partitioning says that we are going to be dividing our data set into train and test. Okay, now say if 80% of the record, or say 80 records I have kept for training, 20 records you can keep for test. Now these 20 records are what? Similar to the training data set. But then as we are going to be using only the first 80 records for training, so we can very well evaluate the model on these 20 records. And for these 20 records, if the model prediction matches with the actual value, we have strong reasons to believe that whatever concept we are trying to teach to the machine is, say, capable in understanding those concepts. Okay, so this is the reason what we do, we partition our data set. Now there are two mechanisms for dividing your data set. One is 2 split and the second one is 3 split. Okay, so actually many I'll say researchers and the AI developers, if they go for 2 split, means they are going to divide their data set into train and test. But then say if you can also find people going for 3 splits, where they divide their data set into train, validation, and test data set. Okay, now what percentage of data we should keep for train and what percentage of data we should keep for test? Okay, or say which one we should use. So mostly people use this one, the two partition thing. Okay, and if you are going for train or test, the most for say common splits are say 70-30 or 80-20. Okay, and if you're going for a train validation and test split like three splits, 60-20-20. This is what is the most followed, or I'll say partition percentage of partition distribution. Is this clear, guys? The first task inside modeling, which is partition, a quick yes or no? Quick yes or no, everyone? Okay. Okay, why should we split in three? We have few questions. And is it always necessary? Chandra Valika, yes. See, when it comes to partitioning, yes, it's always required. Why? Because as I said, before you put your model in production or say in real life use case, you first need to ensure that your model is working properly. And that is where you need to evaluate your model. Okay, and the moment we need to evaluate, what we can do is whatever data set you have, you can divide that into two or three splits. Okay, now many of you are asking, okay, hey, why we need, or what is the difference between 3 and 2, or why we need this validation? See, when it comes to training a model, okay, we train a model in iteration. So model training happens in iteration. Okay, so say if you are training a model using 6 iterations, then in each iteration, what you do is you train your model using trained data set, and then you evaluate your model using validation data set. Okay. So this is when we are going for three splits. So train using train and evaluate using validation. Train, validation, train, validation, train, validation, train, and validation. Now, once you are done with all these iterations, the final evaluation happens using test data set. Okay. So this is the process which say developers follow when they are going for three splits. And mostly we do this when you have sufficient number of data. If you have limited data, you don't need to go for a three-way split. And let's try to understand the same scenario when we are going for, or say, when you are going for two splits, right? So if you are going for only train and test split, then in each iteration, you are going to evaluate your model using train and you are going to train your model using train data set and evaluate using test data set. So in each iteration, this is how it's going to look like. Train using train and evaluate using test. Train using train and evaluate using test, and so on. So as you can see, the purpose of validation or test data set is same. Okay. But then, yeah, if you have sufficient number of data, you can go for three splits. But then there is not much advantage when it comes to going for three-way splits. That is the reason this is the most used, I'll say, partitioning mechanism. Is this clear? Pawan is saying, but validation data is used for hyperparameter tuning. If we don't split three, then how can we determine? Pawan, still it's too early to discuss hyperparameter tuning. But then to answer your question, I'll say we can also use test data set for parameter or hyperparameter tuning. Okay. Is that clear, Pawan? Okay. Now, once we are done with partitioning, the next step is modeling. Okay. Now say modeling is where we train our model using some machine learning algorithm and clean data set. Okay. Now, what this machine learning algorithm is, this is what we are going to be discussing in the course. Okay. So as of now, let's assume that working of this machine learning algorithm for us is a black box. Okay. But then in modeling, what we do, you train your model. What exactly I mean by training? Means you are trying to teach your model concept which are very helpful for your business objective. Like say in sentiment classification example, what exactly we mean by training? We are trying to train a model, or say we are trying to enable a model to predict sentiment of a review. And how can we do that? For that, we need appropriate machine learning algorithm, and we need clean and relevant data set. Okay. So now whatever machine learning algorithm we have, that we can broadly classify into three different parts: supervised, unsupervised, and reinforcement learning. Okay. So let's try to understand what exactly we mean by supervised learning, unsupervised learning, and reinforcement learning. When the model is getting trained on a labeled data set, which have both input and output parameter, it is called supervised learning. Okay. Santosh, black box, by black box, what I mean is, say, as I have used this multiple times, let's say if you have a model which takes review text as input and predicts sentiment, positive or negative. And if I'm saying that M1 is a black box, means we are not sure about internal working principle of M1. Okay. So by black box, we mean that, okay, you know how to use it, but then you have no idea what exactly is happening inside. Is that clear? Is that clear, Santosh? Okay. Now, okay, by modeling, what I mean is training the model. And what do we mean by training? That in machine learning, what we try to do, if you go by the definition, we try to enable machines with human level intelligence, right? So say if we are working on this sentiment classification problem, okay? So what exactly we want a machine to do here? Say if we need to train a model M1, okay, say if this is M1. So we want this model M1 to learn the concept of what is a positive review and what's a negative review, right? Because given any review text, okay, this machine learning model or M1 here, it's supposed to predict sentiment of the review, right? Now, so when it comes to modeling, what we need? We need ML algo, appropriate machine learning algorithm, and clean and relevant data set. And that is where I said, whatever machine learning algorithm we have, we can broadly classify them into three buckets: supervised, unsupervised, and reinforcement learning. And what we are discussing right now is supervised learning. Clear? Okay. So supervised learning, let's check the definition. When the model is getting trained on a labeled data set, which have both input and output parameter, okay, it is called supervised learning. So let's try to understand what do we mean by labeled data set. Say in case of sentiment classification, how our data set will look like? Record one will have some review saying product is good. Okay. And how we want our model in this case to be, which takes some review text as input and predicts sentiment of that review, right? So product is good. Then review two is Say product is bad. Review 3 is delivery is good. Okay. Say review 4 is didn't like the product. Similarly, say if we have n reviews and the nth review says delivery is awesome. Now, as we are trying to train a model which can classify any review into positive or negative sentiment, right? So in supervised learning, we are going to have access to both input and output. So the model that we are trying to train, what is input? Review text, which we have here. So in machine learning, or say in AI world, often we denote input using this capital X. Okay, so this here is what our input. But then at the same time, if you see when the model is getting trained on a labeled data set which have both input and output. So what exactly we mean by this? In case of supervised learning, we are going to have access to the label or tag also. So for example, tag for first review is going to be positive, negative, positive, negative, positive. Okay, and in machine learning, output or label or tag is what we refer using capital Y. Okay, so this X here is what? Input. And then Y is output or call it label. And this entire data set is what? We call this as tagged data set. Is this clear, guys? What is tagged data set? Okay. So if we are clear about tagged data set, supervised learning is where we have access to a tagged data set. Means we are going to have access to both input and output. Or in simple terms, you can say, so in supervised learning, outcomes are going to be predefined. So supervised learning, where the first definition can be where we have access to tagged data set. Means both input and output is going to be well defined. Okay, and the second definition can be where outcome is predefined. Okay, say for example, in case of property price prediction, we know in advance that okay, we need to train a model which can predict the property price. So outcome is what? Property price, and that is well defined before you train the model. Similarly, in case of sentiment classification, outcome is what? Positive or negative sentiment. So even before we train the model, we are very well aware about that the outcome is going to be either positive or negative. So these are the different examples where we use supervised learning: spam filter, predicting house prices, predicting stock market price, disease prediction. This is like given any, say, patient information, you need to predict if someone is suffering from diabetes or not. Okay. Handwriting recognition means given any, say, handwritten image, you need to classify whether that contains 1, 2, 3, 4, or 5 or ABCD, right? Biometric attendance means given say face, you need to classify that face into some or say predefined set of persons. So all these are what? Examples where we know that outcome is well defined. In spam filter, we know that outcome is going to be spam or ham. Predicting house prices, high or low. Predicting house prices, like what exactly is the price. Predicting stock market price, high or say means you're trying to predict whether tomorrow say stock price is going to be high or low or something like that. Okay, in case of disease prediction, suffering from diabetes or not suffering from diabetes, these can be the labels. Okay. Okay, so we have few questions. Sir, if I say nothing is bad in this product, actually I meant good. Nothing is bad in the product. I meant good, but referred words related to negative sentiment. How will this be treated, sir, by machine? Rama Rao, it's too early to discuss that, but then what I can say is we have algorithms like naive ways which can very well handle these things. Okay, say for example, product is not good and product is not bad. So yeah, mostly what happens is we say as a human being, we try to relate this word not with negative sentiment. Okay, but that's not the case. Like here, if you see product is not good, so sentiment is going to be negative, and product is not bad, so sentiment is going to be positive, right? So not here actually is acting as a polarity changer. Means good is what, a positive word, and bad is a negative word. But in the moment these positive words occur with a negation word, so let's call it negation word here. So negation word is what, which can change the polarity. So if negation word occurred with positive, the sentiment is going to be negative. And if negation occurred with a negative, then final sentiment is going to be positive. So there are ways by which we can do this. Okay. Labeled means is a model. No, Sampath. We are talking about labeled data set. Means you have all the inputs and as well as the outcome for all those records. Say, for example, the review which I discussed, right? So say review product is bad. Say the second review is product is good, and sentiment of this is going to be negative and this one is positive. So this is what we call as label. Okay, and this entire data set is what, a labeled data set. Why? Because we have access to input as well as the labels for all those inputs. Then we have a question from Lokesh Babu: on what basis ML will identify whether the document is handwritten or not? Lokesh, that is, say, as a human being, that's our job to collect relevant data set. Okay. So whatever we feed to machine as say handwritten, machine will blindly assume all those as handwritten. So that is where while collecting the data, we'll have to be careful that we only use relevant and clean data. Okay. Ajay, how to know where we are going to be applying this algorithm? Ajay, like we have just started. Okay. So like just bear with me as we go ahead and discuss multiple other algorithms. We're going to be discussing like when to use which particular algorithm. Okay. Cool. So that's about supervised learning. Now let's try to understand why it is known as supervised learning. Okay. Say if I tell you that we have three records, one sec, uh, for property price prediction. Okay, R1, R2, and R3. And then we have also area, say 400 square feet, 600 square feet, and 200 square feet. So this is area. And then we have price as 6,000 INR, 8,000 INR, and 3,000 INR. Okay. And say if this is the model which we are trying to train to predict property price given area, right? So as I said some time back that we train a model in iterations. So say in first iteration, when 400, and say in this machine learning, you have multiple functions, F1, F2, F3. And these functions are actually responsible for predicting property price given some area. And let's simply ignore details of these functions, okay? So say in the first iteration, when we give 400 to M1 and say M1 predicts 5,000 as property price. So predicted value is often referred using this symbol Y cap. Okay, Y cap. X is input, and then this is Y cap. Okay. Now say for this model M1, if this is the predicted value in first iteration, we also have access to the actual value. So actual property price for a property with area 400 is what? 6,000. So actual value we refer using Y. Okay. Now, the moment we have predicted value and actual value, see this is what your predicted value and this is actual value. Now, what we can do is we can also calculate error. Now, what is the error in this case? It's say if we only rely on the positive values, then it's 1000. Error is what? Difference between actual value and the predicted value. Okay. So this is what error. Now, what happens is in supervised learning, we are going to inform model that, hey, whatever function definition you have, this is what is the error. So using this error, model will try to modify its function definition. Why? Because it needs to improve. And what do we mean by improvement? A model is well reliable model when actual value is say very close, or say call it predicted value is very close to the actual value. So what happens is, say in second iteration, right? When you again give 400, now model say predicts 50, 500. Now, as we can see, actual value still is going to be 6,000 and error is only 500. So the moment we inform model about this error after second iteration, now model knows that, okay, it's moving in the right direction, but then still it can improve. So after multiple iterations, we are going to be left with say a model where predicted values are very close to or say equal to the exact value. So what we are doing here, actually using this error, we are trying to supervise the training process, okay, or say the learning process. That, and for supervising, how are we calculating this error? Using actual value. Okay, so now let's try to connect all the dots. Supervised learning is where you have access to data set with label or outcomes are well defined. And what do we do? Using this say labels, we can calculate the error, and using that error we try to supervise the learning process. That is why these algorithms are known as supervised learning. Is this clear, everyone? Is a quick yes or no? Okay. Then comes unsupervised learning. So unsupervised learning is just opposite of supervised learning. In supervised learning, say supervised learning, we just discussed data set with labels, or say outcome is well defined or call it predefined. In case of unsupervised learning, we get data set without labels. Okay. And outcomes are not defined. So clearly you can see here that unsupervised learning is what? Opposite of supervised learning. And then let's try to understand unsupervised learning using an example. Say if I tell you that, okay, we have a basket, okay? And in this basket, we have multiple fruits. Am I audible, guys? Okay. And say this is what your, these are the different fruits which are available, okay, in your basket. Now say if I tell you that, okay, in this basket we have 100 fruits. For all these 100 fruits, I'm going to provide certain features. So say the shape information, then weight per unit, okay, then maybe color. So for all the 100 fruits that we have in the basket, I will say if we have these information. This is a basket. So say it can be it's say elliptical, or say circular, or say cone-like, or say even elliptical. Okay, and then weight per unit, it's something like 400 grams, 100 grams, then say 50 grams and 10 grams. Okay, and color is green, red, then say yellow and red. Say if we are given these. So now what we have, this is what this entire thing is, a data set. But then do we have labels? No. Like, do we have a tag for all these records? No. So in unsupervised learning, we are going to get access to such data set where your labels is not defined, or say outcomes are not defined. So what happens is when you apply unsupervised learning on a data set, what you get is multiple clusters or group. Okay, such that let's call it cluster 1, cluster 2, cluster 3 and cluster 4. Okay, so as I said, when we apply unsupervised learning on a data set, what you get is multiple clusters or group, such that similar items, they are going to be part of one cluster, and all the different items, they are going to be part of a different cluster. Okay, so say we might have something like this. Okay. Now, as we can see in all these clusters, what can we say about these clusters? We don't know what is C1, we don't know what is C2, but then what we can say is that all the items, if they are part of C1, they're going to be similar to each other, and they're going to be very different from all the elements which are in C2, C3 or C4. Similarly, what can we say about C2? All the products or items which are part of C2, they are going to be close to each other, and then very different from all the items of C1, C3 or C4. Okay, so this is what is unsupervised learning, where we are going to have access to a untagged data set or data set without labels, where outcomes are not defined. Why outcomes are not defined? Because say if you apply same, you might get say 4 cluster or 5 cluster or 3 cluster. We don't know in advance that how many clusters we might get after executing an unsupervised learning algorithm. Okay, but then once we apply unsupervised learning algorithm, what we get is multiple clusters or group, such that all the similar items, they are going to be part of one cluster, and all the different items, they will be part of different clusters. Okay, Dibya, again we will see. Okay, so as I said, see, the first module that we have in our course is what? Where we try to understand at a very high level what are the different components of, say, our machine learning or AI. And then we are going to go into details of all these algorithms, okay? So when we discuss multiple clustering algorithm, there we will see how exactly we select the features which can be used for unsupervised or say clustering process, okay? And what are these algorithms, okay? Cool. Next is reinforcement learning. Okay. So now, when it comes to supervised and unsupervised, what have we discussed? That we are going to have access to data set. Okay. In supervised, that data set is going to be tagged, but then when it comes to unsupervised world, that data set is going to be untagged, right? When we talk about reinforcement learning, here we talk about algorithms which we apply when we have access to limited data set. Okay. Or say the data set is not sufficient, or collecting the relevant data is also not possible. That is where we go for reinforcement learning algorithms. Okay. Now, reinforcement learning algorithms are algorithms which are inspired completely by human behavior. Okay. Now, let's try to understand what exactly I mean by human behavior here. See, as a human being, whatever action we take, right? Say for a particular action, if you get praised, or say if you have very good feedback from people around you, then what do? We try to repeat such actions in future. But then say if you take an action for which people around you are not happy about, or let's call it that you get a bad feedback, then we try to avoid such actions in the future, right? So reinforcement learning is actually inspired by this. So in reinforcement learning, what happens is we deploy an agent or machine which try to interact with the environment to solve a particular objective, okay, in multiple iteration. And in multiple iteration, it will end up selecting set of actions such that you have maximum reward and minimum penalty. So I'll repeat the definition once again. Reinforcement learning is an algorithm where agent interacts, or say machine interacts with the environment, and in multiple iterations it will try to select set of actions such that you get maximum reward and minimum penalty. Let's try to understand this using an example. Say this is a road, okay? And reinforcement learning is one of the most important algorithm when it comes to autonomous vehicles. See, if this one is the left lane and this one here is the right lane, okay? See, we have a person here and an animal here, okay? So first I said in reinforcement learning, given an objective, okay? Objective is what? Say, start from a particular point, let's call it starting point, and reach the finishing point. So this is the objective for this machine, which is say a car in our case, right? So objective is start, or say reach finishing point in best possible way. Okay. Now what happens is, as I said, in reinforcement learning, in multiple iterations, model will end up selecting set of actions such that it has maximum reward and minimum penalty. So let's list the set of actions which this model can take. Say the actions are drive in left lane, drive in right lane, change the lane, then hit person, hit the animal, okay? Or say avoid hitting person, avoid hitting animal, okay? And then say last but not the least, stop after reaching finishing point. So see, these are the actions which this machine agent or car can take. And this entire setup is our environment in this case. Okay. So say, let's try to see how first iteration will look like. So in first iteration, when this model is say not aware about reward or penalty associated with these actions, the machine is only aware about the objective, and objective is to reach the finishing point in best possible way. So what are the actions this machine will take? The first action it will take is drive in left lane. Then now in left lane you have a person. So model is not aware whether hitting a person is rewarded or penalized. But then model knows that in order to reach this finishing point in the best possible way, if say model takes a detour, it will take some more time. So what the model will end up doing is hit the person and then stop after reaching the finishing point. Okay, so see, these are the three actions which model took in the first iteration. Now after this, what we can do is we can very well inform the machine that hey, this action is something which you should not take. Why? Because there is very high penalty associated with this. Okay, so let's say high penalty. So in next iteration now, let's see what are the actions this machine will, so this car will take. Drive in left lane. Then the moment it sees person, now the model is aware, and we are talking about the second iteration. So now model is aware that okay, hitting person is highly penalized, so change the lane. Now in right lane, and then the action will be drive in right lane. Now you have an animal in the right lane, but the model is not aware if hitting an animal is rewarded or penalized. So it will end up hitting animal, because objective is to reach the finishing point and stop after reaching finishing point. So what we can do is after the end of second iteration, we can also inform machine that hey, hitting animal is also not allowed. This is something which is also highly penalized. So then in the third iteration, let's see what are the actions this machine will take. Drive in left lane. The moment encounters the person, change lane. Then drive in right lane. Okay, and then the moment it encounters, as we are in third iteration, the moment it encounters the animal, change the lane. Then drive in left lane, and then stop once you reach the finishing point. Okay, so as we can see, after third iteration, the machine here has selected set of actions to complete the objective with maximum reward and minimum penalty. So this is what reinforcement learning is. Now, if you ask, hey, why can't we train this in a supervised way? Because imagine when it comes to autonomous vehicles, what are the different cases that a machine can encounter? Right? There are so many different cases for which generating a data set manually is not feasible. Say, for example, like if we try to imagine the different scenarios, it depends on different geographical location, different countries, different traffic rules, different weather condition, different lighting condition, the say driving pattern, the neighboring vehicles. There are so many things, and we cannot generate a tagged data set for this. And that is why what happens is, say if we have a scenario where you have limited data set, so you try to simulate the environment. In that simulated environment, let the machine interact with the environment, and whatever actions machine takes for a particular objective, after end of a particular iteration, you simply reward or penalize that particular action. And after multiple iterations of training, your model will end up selecting set of actions such that you have maximum reward and minimum penalty. So that is what reinforcement learning is all about. Is this clear, everyone? Guys, a quick yes or no? Okay. Yeah. So these are the different, I'll say, supervised, unsupervised, and reinforcement learning. Say regression algorithm, decision tree, random forest, KNN, SVM, neural network, convolutional neural network, recurrent neural network, say deep learning. Okay, this is what is known as deep learning. Then in unsupervised world, we have multiple clustering algorithm, then dimensionality reduction, recommendation engine. These are all example of unsupervised learning. And then last but not the least, in reinforcement learning, we have Q learning, SARSA, and deep Q network. Okay. Okay, here I guess I missed one thing. Yeah. So these are the examples. Okay. To be very honest, reinforcement learning is still in research. There are very few companies which are using reinforcement learning when it comes to the production. Okay. And as of now, reinforcement learning is mostly getting used in autonomous vehicles and say the gaming world. So this AlphaGo is a game where say a team of researchers, they trained a machine for this particular game AlphaGo, and that machine actually played against the world champion, and they had 5 rounds where machine won 4:1. Okay, and actually this video is available online. Okay, give me a sec. Is my screen visible, everyone? Okay. Yeah, so basically whatever you see here, like this is the game AlphaGo, where this is a Japanese board game, okay? And this, yeah, like this video is actually a movie, okay? And this movie is a documentary. So here, let me just fast forward it. Yeah, yes. So here, yeah, this one is the world champion of AlphaGo. And initially he thought that no, a machine can't beat human being, especially when it comes to AlphaGo. And if I'm not wrong, he like he had won at least 10 or 11 world championship. Okay. But then when he played against AlphaGo, lost by 4:1. Okay. So I'll encourage all of you to kind of go and watch this movie. And yeah, this is very, this is a very good documentary, and will give you more insight about, I'll say, reinforcement learning and what machines can do. Okay. Similarly, we can use reinforcement learning for traffic light control. As I said, in traffic light control, how can we define objective? Objective is that we need minimum traffic and maximum, say, smooth movement of the vehicles, right? So what you can do is you can deploy multiple CCTVs which are going to be controlled by a machine, and machine in itself will control, say, based on the situation, which lane to allow green light and which lane to stop, or say, basically it will coordinate the different lanes so that you get maximum movement of vehicles and minimum traffic jams. Okay. And of course, I discussed this example of autonomous vehicles. Okay. Yeah. So yeah, I was saying these are the different algorithms. So in this course, mostly we are going to be focusing on neural networks, CNN or RNN, because these are nothing but deep learning algorithms. Okay. And we are also going to be discussing multiple clustering algorithm and a very briefly, or I'll say brief introduction to reinforcement learning. Okay. So this is about modeling, the second task that we perform in the model stage, or say the fourth stage. Now let's talk about the third and the last task that we perform in modeling. Okay, that is what? Evaluation. Once we have trained a model, what do we need? We need to evaluate the model. And the example which I gave, say if you are trying to teach a student concept of addition and subtraction, what do we need? We also need to evaluate whether, say, he or she understood the concept or not. And now in order to do that, what we'll have to do, we'll have to have some data set which is similar to what we have used in training, but then at the same time it should be unseen to the student. Why? Because the moment we use same data for evaluating, you might have a situation where a student simply memorized all these stuff. Okay, and that is not gonna give us a very high confidence on whether a student is clear about the concept or not, right? So while evaluation, there are two main tasks that we try to perform. One is we need to ensure that machine, say, is understanding the concept rather than memorizing the stuff. And the second is, what we do in evaluation, we simply try to we simply try to evaluate how far actual value is from predicted value. Okay, and there are multiple ways by which we can do this. Say confusion metrics, accuracy, precision, recall, specificity, F1 score, precision recall. Okay, all these are different ways by which we can evaluate a model. Okay, so yeah, stay tuned. As we discuss multiple algorithms, subsequently we are also going to be discussing these different ways of evaluating a model. Okay. But then quickly let me talk about this confusion matrix. So confusion matrix is what? This is something which we can use for evaluation. Okay. Now what happens is, and I said while evaluation, what do? We try to compare how far actual value is from predicted value. Okay. So say if we have a model for predicting if a patient is suffering from diabetes or not suffering from diabetes, right? So this confusion matrix is nothing but a matrix like structure where we plot actual value against predicted value. So this is how your confusion matrix will look like. Okay. And as I said, it's compare of actual value versus predicted value. So say on the y-axis we have actual values, and on the say x-axis we have predicted values. Okay. So let me give some numbers. So here if you have 200, if you have 400, say 80 and 20. Okay, so this is how your confusion matrix will look like. Now let's see how we read a confusion matrix. Okay, so what do we mean by this 200 number? This here says that in your test data set, you have 200 records where the actual value of the patient is, or say actual state of the patient is suffering from diabetes, and model also predicted that patient is suffering from, a person is suffering from diabetes. Is this clear, guys? This number here is what? In your data set, you have 200 records where actual value is, or say actual state of person is suffering from diabetes, and model also predicted as suffering from diabetes. So can you guys quickly tell me if this is a correct prediction or incorrect prediction? Quick. This is correct prediction. Why? Because actual value is also suffering from diabetes, and model also predicted as suffering from diabetes. Similarly, now let's see what can we say about these 80 records in our data. Okay. Santosh wants me to repeat this again. Santosh, see, what we mean by this is that if you see these 200, in your data set, you have 200 records where actual value or actual state or actual condition of patient is suffering from diabetes. And the model also predicted as they are suffering from diabetes. So this is what? This is a case or a scenario where actual value is matching with predicted value. So model is doing the right prediction. So these 200 records are what? Where model predicted value is actually correct. Is that clear, Santosh? Sorry, Durga Prasad Thutta. Okay. Then now let's talk about these 80 records. We can say that these are the 80 records where actual value is suffering from diabetes, but then model predicted as not suffering from diabetes. Okay. So what type, is this correct or incorrect? Incorrect. Okay. Why? Because these 80 persons are actually suffering from diabetes, but then model prediction is not suffering from diabetes. And this can be fatal or dangerous, right? Similarly, let's talk about these 20 records. What can we say about these 20 records? That patients are actually not suffering from diabetes and model prediction is suffering from diabetes. So this is again what? Incorrect or correct classification? Guys, incorrect classification. Why? Because here the patients are not suffering from diabetes, but the model is saying that no, you are suffering from diabetes. So actual value is not matching with the predicted value. And last but not the least, what can we say about these 400 records? That patients are not suffering from diabetes and they are model is also predicting as not suffering from diabetes. So this is correct prediction. Okay. So this is how your confusion matrix will look like. And I hope it's clear that when I said that these are what? These are ways by which we can evaluate a model. And evaluation is what? Comparing actual value with predicted value. And clearly you can see here in case of a confusion matrix, we are simply trying to evaluate or compare actual value with predicted value. So using this, what we can do is we can calculate accuracy of a model. Okay. And accuracy is what? Correct prediction divided by total prediction. So in this confusion matrix, correct prediction is 200 plus 400 divided by total prediction. Total prediction is 200 plus 80 plus 20 plus 400. So this is 600 by 700. Is this clear, guys? Okay, so if we are clear about this, that basically completes the three different tasks that we perform in the model stage: partition, modeling, and evaluation. Okay. And last but not the least is interpret. This is all about deployment. Means, say once you have trained a model and after evaluating, if you feel that all your model parameters are well within acceptable range, means model is accurate enough to be deployed in production, then what we'll have to do is we'll have to deploy. While deployment, there are multiple things we will have to think about. Say, for example, whether you have an external user. In case you have an external user, in that case, you cannot reveal your code. You'll have to think of a way by which you only let your external users use your product without revealing your code. But then say if you have internal users, you can actually think of a way where you can simply deploy your model and even if say code is getting exposed, you don't need to worry about that. Why? Because that is getting exposed internally. And there are multiple other components which we need to think while deployment. Okay. So this basically here summarizes the Osman framework. Okay. See, so in Osman framework, O is obtain, S is scrub. E is explore. M is model. And N is interpret, right? What we do in obtain? Understand the business problem and collect relevant data. In a scrub, what we do? We pre-process our data, means clean the noise or clean the data. Simply you remove the noises. In explore, what we do? We try to explore and visualize our data set to understand the patterns. In modeling, we first partition our data set, then we train the model, and last but not the least, we evaluate. And in interpret, what we do? We need to think about deployment. Okay. See, this here is awesome one. And I just said in the beginning that one framework is where people talk about the 8 different stages through which any AI project will go through. So those 8 different stages are nothing but one is business problem, second is collect the relevant data, third is pre-processing, fourth is explore and visualize, fifth is partition, sixth is modeling, seven is evaluate, and eight is deployment. So many a time you might see people talking about this framework when it comes to referring to different stages of any AI project. Okay. And then we also discussed that when it comes to modeling, the 3 different types of algorithm that we have is supervised, unsupervised, and reinforcement learning. And how we partition our data set? There are 2 mechanisms. One is where we divide our data set into 2 parts, train and test. And the second is where you can divide your data set into train, validation, and test data set. Okay. Pre-processes all about cleaning data, or call it remove noise. Okay. So yeah, this here marks end of our discussion on introduction to machine learning, okay, or AI. Now we know like what are the different components at a very high level. I'm not saying that we know all these things in detail, but then we have some idea of what exactly we try to achieve through machine learning or AI, and what are the different stages through which any machine learning or AI project will go through, what is the importance of data, why we need to understand the business problem, and so on. So in next, what we are going to do in next few sessions, we are going to understand more about these different stages. Okay. The first one here is business problem. Understand the business problem. Okay. Now, as an AI engineer, mostly we are going to be responsible for pre-processing, explore and visualization, partitioning, modeling, and evaluation. Okay. So more like in most of the data science or AI organizations, they will have, I'll say, a data engineering team and the data platform team. So data engineering team and data platform team, they are responsible for actually say collecting the relevant data according to the business problem. Data engineers or data platform. But then as an AI engineer, what do we need to do? We need to inform very well, say, to our data engineering and data platform team that what type of data we need. Okay. So yeah, but then here again, our job as an AI engineer is to only inform them what type of data we need. And again, when it comes to deployment, you'll have to explain working of, say, working of your model. But then when it comes to deployment, in most of the organizations, you expect some help from data platform team. Okay. So yeah, cool. So that's it for today. Now let's get started with the Q&A session, and feel free to ask whatever questions you have. Which platform is best for deploying the model? Vamsi, there are multiple platforms. Okay, you can use AWS, Azure. You can also use TensorFlow, CherryPy, Flask. It depends completely on the use case. Attendance link, and guys, once again, Mr. Tarun just shared the attendance link, so I request all of you to kindly mark your attendance. It's very important. Please explain confusion metrics. Yeah, as I said, confusion matrix is what? A matrix like structure where we try to visualize actual value with predicted value. Okay. And see, this is how your confusion matrix will look like, which we use for evaluation. Say on one axis, we are going to have AV or actual value. And on the second axis, you're going to have predicted value. Okay. So say if this is class 1, class 2, class 1, class 2. And in class 1, you have 10 records. Here you have 10 records, here 1 and 1. Okay. So the best way to read this is, yeah, the link will start working at 6:30, guys, the attendance link. Okay. So the correct way to read this is, what can we say about these 10 records? These are the 10 records where actual value is class 1. Okay. And how can we say that? Because on this axis, we have actual value. And the model also predicted as C1, right? So for these 10 records, model prediction is correct. Why? Because actual label matched with, say, predicted label. Okay. Similarly, now let's try to understand the second value, 1. Now for this one, what can we say about this record? That we have one record where actual label is class 1, but then model predicted that this particular record belongs to class 2. Okay, so this is what? An incorrect classification. Okay, so this is incorrect. Similarly, for this one, actual label is class 2 and predicted label is class 1. Okay, why I'm saying this is actual value? Because here we have specified that on y-axis we have actual values and on x-axis we have predicted value. So this is also incorrect classification. Then we have, see, these 10 records where actual value is C2 and predicted value is also C2. So this is correct classification. Okay, so accuracy of this model is what? Correct prediction, which is we have 20 records where the prediction is correct divided by 10 plus 10 plus 1 plus 1, because model predicted value for 22 records. Okay. Guys, one by one, I'll request all of you to take some gap between you ask your questions so that I don't lose track of the questions. Okay. Uh, is this clear, guys? The confusion matrix, whoever asked, I have lost the track of your name. Yeah, ye achiever. Okay, if possible, kindly modify your name, but then let me know if this is clear or not. Okay. After completing this course, can I apply for data analyst position? Yeah, see, as a data analyst, this course is going to be more than sufficient, but then at the same time, there are certain statistical technique which you'll have to learn. Okay. Uh, yeah, the guys, as I said, link will be active after 6:30. Okay. Then we have a question, which models would we use for sales forecasting application? A WMC time series models is what we use for forecasting. Okay. ML is more about matrices? No, Sridhar. There are multiple components in ML. We cannot simply say that ML is all about matrices. Okay. Is there any practical? Yes, of course, guys. See, this is the first module. Okay. In next many modules, we are going to have hands-on also. And we are going to have, say, where what we'll do is we'll actually train the model using Python on some data set. Okay. And for all such hands-on, we are going to share the data set as well as the code with you. The material is something which we are not going to share with you guys, but then yeah, the relevant person at EXCELR side, we are going to share, say, the code and the data set with all of you. Is there any relationship between precision and recall? Jayapal, yes, precision and recall is something which we calculate using confusion metrics. And we will discuss more about precision and recall once we start our discussion on classification algorithm. Deep learning, COSIC, as I said, comes under supervised learning. Okay. Is there any change in the values of cells C1 and C2? Like in this case, no. Like this C1 and C2 is what? This confusion matrix you can draw only when you have trained a model. Okay. So ideally it should not change. What about statistics? Yes, Sridhar, we are going to be discussing few basic mathematical, tricks, whatever is required for AI. While coding of confusion matrix, does it appear same, that is numerical format? Yes, Hemant. Like once we start our discussion on classification modules, we are going to be drawing multiple, say, confusion metrics, and this is how it will appear. Is data scientists and AI engineers are same or different? Ganesh, as I said, say yesterday, more or less they are same, but then there is some fine difference. Okay. Machine learning is one of the most important component for both data science or AI. Guys, it's 6:31 and link is going to be active, so feel free to mark your attendance over there. Dibya, is below is the work structure, O is for data scientist? No, 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 no. Dibya, as I said, like Obtain is where mostly data engineers and data platform engineers are going to be working, okay? And same for N. When it comes to S, E, and M, that is where data scientists or say AI, ML engineer comes into the picture. Sujan is asking, please explain reinforcement learning. Sujan, reinforcement learning is a type of learning which is inspired by human behavior. Okay, so as a human being, we have this tendency that we repeat actions for which we get praise, right? So say if you perform an action and if people around you are happy about it, then you try to repeat such actions in the future. But then say the moment you say took an action which people around you are not happy about, right? So we try to avoid such actions in the future. So this is how reinforcement learning work. Okay, the formal definition that we can have is reinforcement learning is a type of learning where model interacts with the environment, and in multiple iterations it will select set of actions such that they have maximum reward and minimum penalty. Coding part of confusion matrix, again guys, it's too early, we have not yet started coding. Okay, see, the flow is after this we are going to be starting our discussion on basics of Python. I know many of you are completely new to the programming, so first we are going to discuss basics of Python. Okay, and then we will start our AI journey. And maybe if not, say on next Monday, max by Tuesday or Wednesday, we are going to be sharing the detailed agenda for this course. So you'll have a clear-cut idea of what are the topics that we are going to be covering and the sequence in which we are going to cover those topics. Okay. Without learning Python, can I understand this course? No, Rekha, you can't. Do I need to be good in mathematics for ML? At least to start with, high school mathematics is going to be sufficient enough. Okay. Can we have study materials? No. Whatever courses, whatever sessions we are going to have, all these videos are going to be up on YouTube, and whatever code or say data set we will use, that is going to be available with you. Okay, not the material or the PPT which I'm using here. Guys, once again, make sure that you mark your attendance. Okay. Yes, as I said, max by Tuesday or Wednesday, we are going to be sharing the detailed agenda for this course. Is there any difference between supervised and reinforcement? Charan, yes. As I said, in supervised, we are going to have access to a data set with labels, right? And in reinforcement learning, mostly we apply where we have very limited or say no data set. Okay. Lavanya, is Python needed in advance or some basics can be used? We are going to be starting with basics of Python, and we will discuss almost all the components of Python, whatever is required for AI. Okay. So even if you are new to programming, if you follow with, say, the agenda that we have for this course, and if you practice enough, uh, it's going to be sufficient enough. When will the next class be held? Vamsi, Monday is when we are going to have the next class. So these sessions we are going to have Monday to Friday, 5 to 7 p.m. Is there any fresher requirements for data scientists or AI engineer? Yes, of course there are. Are we going to say do some real-time projects? See, at least in this course, we're going to have multiple use cases where we use some real-life data set and try to solve that using AI. Okay. We have no sessions on Saturday and Sunday. Do we have a WhatsApp group? Shrita, I'm not sure. I'll have to check with the management and we'll let you know. Uh, yes, the schedule for this class is Monday to Friday, 5 to 7. What about R? No, we're not going to be using R in this. No, no class on Saturday or no classes on Saturday and Sunday. Uh, so Vishnu, we have shared attendance link multiple times. Okay, so let me know if you are still unable to access that. To understand this, do we need to learn Python? See, Reddy, like, when it comes to understanding, that's fine, you can only orient this course, but then the real understanding happens when you start implementing these things, and the moment we talk about implementation, you need to understand Python. You cannot implement this without Python. Akhil is saying, can we use fourth option like recheck and test train validation? Not required, Akhil. Okay, like as long as the objective is same, why you wanna unnecessarily increase the number of splits? Data science is similar to big data? No. Data science is where we try to extract actionable insight from the data, and big data is a technique where we talk about efficiently storing the data points. Okay, and that to large data sets. Without Python and with high class mathematics, do we understand course? Durga Prasad, as I said, you can only audit, but then like without Python, you cannot expect to have a complete understanding of AI. Is AI useful for electronics industry? Chandra, AI is horizontal innovation. So this is something which is, say, you can find application of AI everywhere. Thank you so much, sir. Nice explanation. Thanks. Calculus is important. Yes, initially basics of calculus is important, but then yeah, again, like as I said, don't worry if you are not clear about this, because as we go, we are going to be discussing whatever mathematics is required. I have Python basics. Yes, that's sufficient. Except Python, can we use any other language? Yes, of course. You can use many other languages. Like you can use also use R or Java or C++. But then when it comes to AI, Python is the most used programming language. Can we use Python for MATLAB based AI? Hey, MATLAB is like Python, a tool for programming. Okay, so you can use that, but then that is not something. MATLAB is not something which you want to discuss in this course. Jai Ram, can I use this course to join in TCS given that I'm a civil engineer? Uh, I'm not sure what is their, say, basic requirement or prerequisite for an AI or ML role. But then, yeah, most of the companies I have seen where background is not important, whether you are from CS engineer or say civil engineer or mechanical engineer. What matters is as long as you know the concepts of machine learning or AI very well, you can apply for the job. Can we apply Java language on your ML and AI techniques? So yes, of course, you can do that. But then, as I said, again, here in this course, we're not going to be discussing Java. How do we get data sets? Yogesh, we are going to be sharing that with you guys. What type of jobs we can apply after this course? Say machine learning engineers, AI engineers, NLP engineers, computer vision engineers. So these are the profiles which you can actually go for. Durga, whatever Python is required for AI is something which we're going to be discussing in this course. Yeah, so whatever, say, buckets of algorithms we have discussed, like supervised, unsupervised, and reinforcement, mostly in this course, we are going to discussing supervised algorithms, then unsupervised, and a very brief intro to reinforcement learning. Ganesh is asking, as a fresher, can I go for data science or ML role? Because someone said that there are no roles available for freshers. That's not the case, Ganesh. There are many roles which are available for freshers as a data scientist. Okay, you just need to apply to right channels and work very well on your machine learning or AI skills. I know SQL. Is there any helpful in AI? So yes, SQL is also say very similar to programming. So if you have SQL knowledge, one is of course you can very well work with SQL database, and your understanding of SQL is going to be helpful in your programming. Anything else? C, Java or JavaScript. Again, you can use even C or Java or JavaScript, but then not the best language to implement AI. Nice session, sir. Thank you. Anything else, guys? Any more questions? Cool. So if there are no more questions, that's it for today, guys. We meet again on Monday, 5 to 7. And make sure if you get time, try to go through these videos, whatever we have recorded. And yeah, see you all on Monday, 5 to 7. Bye-bye. Without DS and ML, is AI will work, sir? Durga, please go and check yesterday's video where I explained the relationship between data science, machine learning, and AI. Okay, so mostly in AI we discuss machine learning algorithms. Practically, more or less, they are same. Okay. Salary for AI for freshers, again, it depends. Okay. Maybe this is not the right platform to answer this. Again, at the same time, I don't want to be controversial, but then there are like compared with multiple other profiles, you get high salary for machine learning or AI professional. But having said that, as I said, it's all about how well you acquire these things. Please suggest some book uh, like okay, give me some time and I will do that. But then if you guys are say if you want to explore, you can explore multiple machine learning books by O'Reilly publication. Okay. Yeah, there are multiple platforms which you can use in order to learn Python in detail. You can check Geeks for Geeks, okay, or say tutorial points. They have few, I'll say, good material on I'll say Python. O'Reilly, Oreilly. O'Reilly, Oreilly. Yeah. Okay, so that's it for today, guys. Bye bye. See you all on Monday.